Welcome to Homework Lib.
Hi, so for this question, essentially what we're looking at is a scenario when we have a common ion effect. So we're starting with a zero point 0.2 molar solution of HF, and which also have zero point 0.4 molar of HCl. Okay? So now, first thing that we need to notice, HCl is a strong acid. So those for 0point 0.4 molar is the same as saying that we have an initial value of 0point 0.4 molar of H plus or hydronium ion, whichever you prefer to use. Here I'm going to stick with H3O plus, the hydronium ion, because of the definition that you're giving here. So we need to take into account that initial concentration of H plus when we want to calculate what is going to be the value for F minus. Okay. So the reaction that we are looking at is the dissociation of HF in aqueous solution with water producing and in equilibrium with H3O plus F minus in aqueous solution. So we can solve this directly by using our ice table. We're already given the concentrations. So for HF, we're going to have 0point 0.2 molar. For water, it doesn't matter, it's a pure substance. For H3O plus, the initial concentration, it is going to be 0point 0.4 molar. And for fluoride, it's going to be 0. Now let's call the amount of change that we're going to have, the amount that dissociated, which is going to be minus x. The amount of change of hydronium, it is going to be plus x. And the amount of change of F minus, it's also going to be plus x. Okay. This means that at equilibrium, what I'm going to have is 0point 0.2 minus x, 0point 0.4 plus x, and of F minus, I'm simply going to have x. Oops, that x looks a little bit off, so let's redraw it. X. Now we can write down our acidity constant for HF, which we know that is 6.8 times 10 to the minus 4. So it is a small constant. So we would expect the dissociation to be very small. We are going to look at what approximation we can make here and which one we cannot. This is going to be H3O plus times concentration of a F minus divided by the concentration of HF. So this becomes 0point 0.4 plus x times x divided by 0point 0.2 minus x. Right? So there are two routes that we can take. The first one is solve the quadratic equation. And the second one is rationalizing the fact that if the dissociation constant for this is 10 to the minus 4, then that value, if x is much smaller than 0point 0.2, this would imply that 0point 0.4 plus x would be approximately 0point 0.4. And that 0point 0.2 minus x would be approximately 0point 0.2. Okay. So we can solve it both ways. For the first one, we're going to use the approximation. And then we're going to verify if that approximation makes sense. If the approximation makes sense, the result of x that we are going to find, it is going to be much smaller than 0.2. Okay? So using that approximation, the equation becomes 6.8 times 10 to the minus 4. It's going to be equal to 0.4. here is the first quantity that we approximated, times x divided by 0.2. Thus, x is going to be 6.8 times 10 to the minus 4. 0.4 divided by 0.2 is 2. It passes dividing, so divide by 2. So x would be 3.4 times 10 to the minus 4. Nice thing about this procedure, we don't need to do any operation in the calculator. Everything is simple math. And remember that that value for x is equal to the concentration of F minus. And we can use that value for x for finding the concentration of H3O plus, which we said that was 0.4 plus x. So 0.4 plus 3.4x exponential to the minus 4 is essentially 0.4. So it looks like our approximation actually makes sense. But we can use the full value just for verifying it, right? So now pH is equal to minus the logarithm of the concentration of hydronium, which is 0.39. Actually, 3975. We can say that this is approximately 0.4. If you just use one decimal point, because most of pH meters only have a resolution of 1 when you're doing labs. Okay, so this is going to be the answer. Now let's just verify that the value for x that we found is correct. And for doing that, you can plug in directly the equation in any solver that you want. Okay, the full equation that we have, this one. So the result without approximation is, with no approximation and solving the full quadratic equation, we find x equals 3.39 times 10 to the minus 4. So the result is essentially the same. The value for x is correct enough with 3.4 times 10 to the minus 4. So the approximation works. And that would be all.